Good morning, students. In this present class, we are going to discuss regarding a problem related to sinking of supports with respect to slope deflection method. So, first, what do you mean by sinking of supports? So, in last class, I have discussed regarding slope deflection equation and how to solve normal problem without sinking of supports in case of beams. Let me consider what is meant by sinking of supports. Sinking of supports. See, generally, if the particular joint, it may be so they will give like a data like analyze the beam is having some much of loads, and joint A is sinking 2 mm with respect to support A. Like that, you may expect questions in examination. So I'll take one simple question. Analyze the continuous beam by slope deflection method if support B sinks by 2 mm relatively with respect to A. Relatively with respect to A. Also draw BMD. Also draw BMD. So in this problem, you are having 3 joints A, B, C. AB span of UDL 20 kN per meter over a span of 6 meter, and this is subjected to 30 kN, 2 meter, 2 meter. Here I will give this as EI and 2 EI, EI and 2 EI. So in this case of problem, B sinks by 2 mm relatively with respect to A. Compute the what is the final moments and also sketch the BMD. This is very simple problem. So as I told that the very first step is determination of kinematic indeterminacy. So depending on kinematic indeterminacy, we are going to determine the unknowns, and by substituting those unknowns in slope deflection equation, we are getting the final end moments. So the kinematic indeterminacy of a given structure, the kinematic indeterminacy of given structure with respect to joint ABC is, so, and also I told that keep in your mind that if we are going to assume all structure is axially rigid, if we are going to assume the all structure is axially rigid means there is no deformation in along the axis. X-axis deformation is 0, Y-axis deformation is also 0. We are considering only rotations as displacements. So in this problem, the possible displacement at each joints are 2 translation and 1 rotation. 2 translation and 1 rotation. But if we are assuming that axially rigid, then along the axis there is no displacements. Along the axis X and Y there is no displacement. Why? Because we are assuming the beam is said to be axially rigid. And the possible displacements are rotations. Theta A is possible, theta B is possible, and theta C is also possible. So the unknown displacements are 3. K equals 3. That is theta A, theta B, and theta C. There are 3 unknown displacements. So the second step. What is the second step? The second step is FEM. The second step is FEM, fixed end moments. Here I am assuming AB as fixed. AB as fixed. 20 kN meter. AB and MFAB equal minus WL square by 12. We know that this is resisting moment is anti-clockwise. Here resisting moment is clockwise. So minus 20 into 6 square by 12. Minus 20 into 6 square by 12.
Minus 60.
Minus 60 kilonewton meter. Minus 60 kilonewton meter. Similarly, MFBA equals WL square by 12. W is 20 into 6 square by 12. This is plus 60 kilonewton meter. Plus 60 kilonewton meter. Next, I am assuming the span BC to be fixed. BC to be fixed. So this is resisting moment. BC is anti-clockwise, CB is clockwise, and it is carrying a point load, central point load of 30 kilonewton at 2 meter and 2 meter. Therefore, MFBC equal minus WL by 8 minus 30 into L is 4 divided by 8 minus WL by 8
Minus 15.
minus 15 kilonewton meter. Minus 15 kilonewton meter. Similarly, MFCB equals plus WL by 8 plus WL by 8. This is plus 15 kilonewton meter. Kilonewton meter is the moment. So this is regarding the second step, fixed end moments. The very first step is determination of kinematic indeterminates. Here there are three indeterminacy, that is theta A, theta B and theta C. In second step, we determine regarding with respect to fixed end moments. We are assuming each span to be fixed and applying formulas, we are getting fixed end moments. The third step is very important, that is SD equation, slope deflection equation. The third step is very important, that is slope deflection equation. See, originally the thing is the beam is like this along a straight line A, B, C. This is the beam, original beam. But what the thing is given? Is given that B sinks by 2 mm. 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 Relatively with respect to A. Relatively with respect to A. See, this is the original beam. Now, your beam sinks by 2 mm. 2 mm. 2 mm relatively with respect to A. Now, this is the original pattern of the beam. Now, you just observe, because of clockwise rotation theta A, because of clockwise rotation, the beam will deflect with respect to baseline. With respect to baseline, because of clockwise rotation, it deflected below AB, and BC is also same clockwise. But if you observe BC, this is anti-clockwise. If you observe BC or CB, anti-clockwise. So while you are solving, please keep in your mind, the thing is, you know the slope deflection equation, MAB equals MFAB plus 2EI by L into 2 theta A plus theta B plus or minus 3 delta by L, plus or minus 3 delta by L. So here I am having plus or minus. When we use plus delta by L, when we use minus 3 delta by L, that is very important thing. Here please keep in your mind that AB span, AB equal BA, for this deflection pattern, which type of rotation is responsible? Clockwise or anti-clockwise? See, here it is clockwise. See, always when you are solving sinking support problem, clockwise rotations will cause negative deflections. Anti-clockwise deflection, anti-clockwise rotations cause positive deflection, which means delta A equals delta AB, which is equal delta BA, it is clockwise rotation. It is responsible to sag the beam below the baseline, which is see, this is the baseline. With respect to baseline, the only possibility is it can sag below or it can sag above. There are two possibilities. But in this case, for sagging, which type of rotations are responsible? To sag below the baseline, clockwise rotations are responsible. Hence, it is below the baseline. Hence, the sign is negative. Hence, the beam deflect below the baseline, which means that is negative. But if you observe, now this is the baseline. With respect to baseline, the beam BC is above the baseline. You just observe, it is above the baseline. Which type of rotations are responsible? This is not a moment, that is a rotation. Which type of rotation? Anti-clockwise rotation. Anti-clockwise rotation will lift the beam, while clockwise rotations are sag the beam. That's a very, very important thing. So delta AB equal to delta BA minus 2 millimeter. So 2 divided by 1000. 2 divided by 1000. So minus
2 into 10 raised to minus
0.002 meters. 0.002 meters. Similarly, BC is above the baseline. Therefore, delta BC, which is equal to delta CB plus 2 mm. Plus 2 mm. Why plus 2 mm? It is above the baseline. Anti-clockwise rotations are responsible for positive delta. Clockwise rotations are responsible for negative delta. So here you are getting 0.002 meters. Now applying this equation. MAB equals MFAB minus 60 plus 2 into EI. 2 into EI by L. L is 6. 2 theta A plus theta B. Here minus 3 times of 0.002 divided by L. Divided by L is 4. L is 4. Now minus 60 plus 2 into 2, 4. 4 by 6. 4 by 6.
0.66.
0.66 EI into theta A plus 2 by 6. 2 by 6.
0.33.
0.33 EI into theta B minus 2 into 3, 6. 6 by 6 cancels. So 0.002 by 4. 0.002 by 4. 0.002 by 4.
0.005.
0.0005. 0.005 EI. See, while you are getting thinking supports, generally they will give EI value. Generally they will provide EI value. So in this problem I will give EI equals 2 into 10 power 4 kilonewton meter square. So 2 into 10 power 4. 2 into 10 power 4. So generally for sinking support 100% they will provide EI value. Clear? Because here you are getting EI. So EI is not the unknown. So for all sinking support problem they will give EI data in the problem. They will give like E separately 2 into 10 power 5 Newton per mm square or I in Newton per mm cube, like that they will give separately, or else they will give totally EI. Okay, so you substitute EI value. In this problem EI given as 2 into 10 power 4. 2 into 10 power 4. So minus 60 plus 0.66 into 2 into 10 power 4 E theta A plus 0.33 EI into 2 into 10 power 4. 0.33 into 2 into 10 power 4 into theta B minus 0.005 into 2 into 10 power 4. Yes, MAB equal first I will take theta A 0.66 into 2 into 10 power 4
13,200
into 10 power 4 ಹೇಳಪ್ಪ 0.66 into 2 into 10 power 4.
13,200.
13,200 theta A plus 0.33 into 2 into 10 power 4.
6,600.
6,600 theta B. Now, ಇದನ್ನ ಮಾಡೋಣ ಫಸ್ಟ್ 0.00005 into 2 into 10 power 4
10.
plus 60
70.
70. Therefore, minus 70. Say equation 1. Say equation 1. The thing is just substitution. 100% they will provide EI value. You just substitute. You are getting equation 1. Now, similarly MBA. MBA equals plus 60 plus 2 into EI value. I have given 2 into 10 power 4 divided by L is 6 into 2 theta B. 2 theta B plus theta A. Here minus AB equal BA. AB equal BA. Minus 3 into 0.002 divided by L. L. Yes. Now compute MBA. 60 plus 2 into 2 into 2.
2 into 2 into 2.
2 into 2 into 2 into 10 power 4 divided by 6.
13,333.
13,333.
0.33.
0.33. Yes. 0.34 theta B plus 2 into 2 into 10 power 4 by 6. Divided by 2 ಮಾಡಿದ್ರೆ ಅಷ್ಟೇ ಬರುತ್ತೆ.
6,666.
6,666. Point
66.
66 theta A. This is half. Okay. Next 2 into 2 into 3 into 0.002 into 10 power 4 divided by 6 4s are 24.
0.002.
Right.
Divided by 4.
Divided by 64. 24. 6 4s are 24.
0.001.
0.001. ಇನ್ನೊಂದ್ಸರಿ ಮಾಡಮ್ಮ.
2 into
2 into
2 into
2 into 10 power 4 into
3 ಇಲ್ವಾ?
ಇಲ್ಲ ಆಮೇಲೆ ಮಾಡು ತೊಂದರೆ ಇಲ್ಲ. 2 into 2 into 10 power 4 into 3 into 0.002 divided by ಅಲ್ಲ ಈಕ್ವಲ್ಸ್ ಮಾಡಿದ್ಯಾ? divided by 6 4s are 24. 10. Right? So minus 10. Plus into minus 10. Same ಬರಲೇಬೇಕಲ್ಲ, ಇಲ್ಲೂ ಸೇಮ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಇದೆ. ಇಲ್ಲಿ 10 ಬಂದಿತ್ತು. So similar 10 we can expect here also. Right? But here minus 10 minus 60 will become minus 70. Here minus 10 plus 60 will become 50. Clear? Now MBA equals first I am writing theta A factors 666.66 theta A plus 1333.34 theta B plus 50. Say equation number 2. Clear? Next MBC equals MFBC minus 15 plus 2 into EI 2 into 2 EI 2 into 2 into 2 into 10 power 4 2 into 2 EI because here EI value is 2 EI divided by 2 EI by L. L is 4 into 2 theta B plus theta C plus or minus, but here plus because this is above the baseline. BC equals CB positive plus 3 into 0.002 3 delta by L is 4. So once again MBC equals minus 15 plus 2 into 2 into 2 into 2 16 into 10 power 4 divided by 4.
40,000.
40,000
1,000.
theta b plus 2 into 2 into 2 into 2 to the 4 to 8 by 4 2 into 10 power 4, which means 20,000 theta c. Next 2 into 2 into 2 into 10 power 4 into 3 into 0.002 divided by 4 4 is 16.
3 ಆದ್ಮೇಲೆ divided by 3 into
0.002 divided by 16.
30.
30 plus 30 plus 30. This is plus 30 here because plus 30. So next MBC equals first I am writing theta b factor, that is 40,000 theta b plus 20,000 theta c plus 30 minus 15. You are getting plus 15. So equation 3. This is very important problem for 20 marks problem. Please concentrate. Clear? So this is MBC. Next MCB. MFCB is plus 15 plus 2 into 2 EI 2 into 2 into 10 power 4 EI divided by L is 4 into 2 theta C plus theta B. This is plus 0.002 plus 3 into 0.002 divided by L. L is 4. Now MCB equals 15 plus 2 into 2 into 2. 2 into 2 into 2. 2 to the 4. 4 to the 8. 8 into 10 power 4. 8 into 10 power 4. 8 into 10 power 4 into 2 divided by 4. Into 2 divided by 4. This is the value?
40,000.
Yes, 40,000. 40,000 theta c. Next, this is a half. There is no 2 multiplication. Just vice versa. Here it 40,000 will come. Next 20,000 will come. Plus 20,000 theta b. Plus 20,000 theta b. And plus, this is same. You just multiply with the same value, right? Have to multiply with the same value. We are getting 30. Plus 30. Very simple. Next, MCB equals, first I am writing theta b value, 20,000 theta b plus 40,000 theta c plus 45 plus 15 plus 30 plus 45. Here this is plus 30 minus 15. Here this is plus 30 plus 15. It will become plus 45. Now it will become equation number 2, 3, 4. This is equation number 4. Equation number 4. Now, next step. This is the third step. Third step is slope deflection equation. Next, the fourth step is joint equilibrium condition. Joint equilibrium condition. In joint equilibrium condition, if your end support is fixed, then they are already in equilibrium, or else we have to apply the joint equilibrium condition. In this problem, all supports are simply supported, right? It's a simple props. This is intermediate, is also prop. So we are getting 3. What is the number of kinematic intervals? The same number of joint equilibrium condition we are getting. Here we are having 3 number of kinematic indeterminates. So we are getting 3 number of joint equilibrium condition. For joint A, MAB equals 0. For joint B, BA plus BC equals 0. For joint C, CB equals 0. So first joint A. For joint A, MAB equals 0. Please remember, at Joint A we are having simple support, hence we are getting joint equilibrium condition. If in case I am going to provide fixity, then there is no joint equilibrium condition, because fixed joint is already a rigid joint, it's already in equilibrium. Clear? So MAB equals 0. What is the value of MAB? What's the value of MAB? 13,200
Theta A
theta A
plus 6,000.
plus
66,000.
6,600 theta B equals 70. Say equation A. Say equation A. Next, joint B. Joint B. Joint B. At joint B, MBA plus MBC equals 0. At joint B, MBA plus MBC equals 0. What is the value of MBA? MBA here, right? 6,666.66 theta A plus 13,333.34 theta B plus 50. What is the value of MBC? Here, MBC plus 40,000 theta B plus 20,000 theta C plus 15 equals 0. First theta A, next theta B, theta C. There are three things, three unknowns. We are getting three things. So first theta A, only one theta A value. So 66.66 theta A plus theta B, 40,000 plus 13,000. It will become 53,000 plus 53,333.34 theta B plus 20,000 theta C equals minus 15. Equals minus 15. We take this as equation B. Equation B. Next, joint C. At joint C, MCB equals 0. MCB equals 0. What is the value of MCB? 20,000 theta B plus 40,000 theta C equals minus 45. Say that is equation C. Equation C. Now solve equation ABC. There are three unknowns. Right? Now we have to solve those three simultaneous equations. We are getting the value of theta A, theta B, theta C. So next step is fifth step, final moments. Fifth step, determination of, not final moment, that is determination of unknowns. Determination of unknowns. So solve equation A, B and C. Solve equation A, B and C. So here we are having three unknowns. So we have to feed three quotients. We are getting the values. First I am taking theta A, theta B, theta C. That is ax square plus bx plus c equals 0 in the form. So we have to substitute the things. So first A1 quotient is 13,200 equals B1 quotient is 6,600 equals C. Theta C is 0. Theta C is 0 in first equation equals 70. Next A2. A2 is this theta A 6,666.66 equals 53,333.34 equals 20,000 equals minus 15. A3. Here theta A is 0. 0 equals theta B is 20,000 equals theta C is 40,000 equals minus 45. If you just solve you are getting the value of theta A, theta B, theta C. So you are getting theta A value as 5.66 into 10 power minus 3. Next, theta B as minus 6.96 into 10 power minus 4, and theta C as minus 7.76 into 10 power minus 4. This is the value of theta A, theta B, and theta C. Now the last step is substitute these values in equation 1, 2, 3, 4. We are getting the values of theta A, theta B, theta C. Not, we are getting the value of MAB, MBA, MBC, MCB. The last step is final moments. Final moments. So what is the value of MAB? MAB. We have to get 0. We will check now. Please take the calculator. MAB 13,200 multiplied by 5.6 into 10 power minus 3 equals, okay, next answer plus 6,000 bracket open 6,000 multiplied by minus 6.96 6,600
into
multiplied by minus 6.96 into 10 power minus 4. Okay, how much?
69.
Yes, 69.9 is 70. Okay, 70 minus 70? 0. Obviously, fixed end we are getting 0 moments. Right? Now MAB equal 0. 70 minus 70 is 0. Clear? Similarly, MBA. Please look at this. MBA 6,666.66 multiplied by 5.66 into 10 power minus 3. 5.66 into 10 power minus 3 plus bracket open 13,333.34 bracket open multiplied by bracket open theta B minus 6.96 into 10 power minus 4 plus 666.66 multiplied by theta A, that is how much?
into theta A. Theta A.
MBA, right? Wait. First madam, 6,666.66 multiplied by 5.66 into 10 power minus 3.
10 power minus 3.
Okay. Plus 13,333.34 multiplied by minus 6.96 into 10 power minus 4 equals plus 50. 78.44 kilonewton meter. Next, please check MBC. This one 40,000 multiplied by minus 6.96 into 10 power minus 4 plus 20,000 multiplied by
minus 28.36
multiplied by minus 7.76 into 10 power minus 4 plus 50
minus 28.36
minus
28.36.
we have to get MBA plus MBC. So we have to get at least the value of minus 78.44. Please check once this equation now. Let's give the calculator. That is 6666.66 multiplied by theta A. Theta A is 5.66 into 10 power minus 3. 10 power minus 3 plus 50. BC 40,000 multiplied by minus 6.96 into 10 power minus 4 plus 20,000 multiplied by theta C minus 7.76 into 10 power minus 4 15. MBA, MAB, MAB is 0, right? Theta A, theta B. Here MBC, MAB, MBA. So by back substitution, the thing is we know the theta A, theta B, theta C value. Substitute these values in MAB, MBA, MBC and MCB. We are getting MAB equals 0 and MBA equals 66 and MBC equals minus 66 and MCB equals 0. You just substitute the values of theta A, theta B, theta C in equation 1, 2, 3 and 4. The last step is BMD. The last step, very last step is BMD, bending moment diagram. It's very simple. For bending moment diagram, we are having two span A, B and C. A, B and C. First AB we are having UDL. First I will draw free BMD. For free BMD for span having UDL throughout is parabolic and the equation is WL square by 8. Just substitute W as 20, L square is 6 square by 8. 20 into 6 square by 8.
90.
90. You are getting 90. Next you are having the point load at exactly center, that is WL by 4. For that free BMD is WL by 4. WL by 4. The W value is 30. L is 4 by 4. You are getting 30 kilonewton meter. 30 kilonewton meter. First you just draw the free bending moment diagram. Next you draw whatever the value obtained in final moments. For simple supports A and C you are having 0, but at B you are having 66. You just mark this is 66. Now you just join this. You are getting the bending moment diagram. Just shade this portions. This is not common. Unshade the combined areas. This is bending moment diagram. BMD. This is the problem for 20 marks. I hope getting the things. I will explain once again the steps clearly. First, kinematic indeterminacy depending on given support conditions. Here 3 because we are assuming axially rigid. At axis we are ignoring the kinematic indeterminacy 0, 0, 0, 0, 0, 0, only theta A, theta B, theta C. Please keep in your mind when you are solving whatever the method, maybe slope deflection or maybe moment distribution or Canis, whatever the method, irrespective of methods, here we are considering rotations as unknown displacements and delta in case of frames. But in case of beams, you are getting only rotations as unknown, kinematics unknowns. So theta A, theta B, theta C are 3 unknowns. In step number 2, FEM, I already explained the things. You just remember the equations, substitute the equations, you are getting the values. Next, slope deflection equation. In slope deflection equation, first observe the things. In this particular problem, B sinks by 2 mm relatively with respect to A. So when it is displacing relatively downwards with respect to A, which kind of rotation is responsible for downward deflection? Clockwise. That's why negative. Why it is negative? It sinks below the baseline. Above the baseline is positive, below the baseline is negative. You observe the beam with respect to A, it is below, negative. So AB and BA both are negative. So 2 mm, 2 by 1000, so 0.002 meters. But if you observe BC with respect to C, B is above the baseline. So that is positive. For positive displacement, which type of rotations are possible? Anti-clockwise. So this is 2 meters, 2 mm, 2 by 1000, 0.002 meters. So substitute all the things in slope deflection equation, you are getting same equations. In next step, apply joint equilibrium condition. The only thing you have to remember is, if the joint is rigid joint, then the displacement is 0. For all other kind of joints, you are getting equations. Here you are having 3 kinematic indeterminates, so you are getting 3 equations to determine these 3 unknown kinematic indeterminates. So you are getting 3 simultaneous equations A, B, C. In next step, solve these 3 equations. You are getting kinematic indeterminates theta A, theta B, theta C. Once you got these value, substitute by 2 in step number 3 in all 4 equations. You are getting final moments. Finally, draw the BMD. This is the 20 marks question, one full question in your examination. Please concentrate the things. This is regarding sinking of supports problem with respect to B. Thank you.